Hey guys, how's it going? Hope you guys had a Merry Christmas and a fun New Year's. So getting back at it, we got a few weeks here before the end of the semester, which is rapidly approaching. So we got like 3 weeks, and then we'll have exam week, and then we're done with the semester. So we're going to start chapter 4 today. I do want to, or sorry, chapter 3. We're going to start chapter 3 today. I do want to let you guys know that chapter 3 is kind of a weird chapter. The author of this book did something really weird, which is like the first half of the chapter and the second half of the chapter have literally nothing to do with each other. So I don't like to teach this chapter as one whole big chapter. I like to do it as two mini chapters. So we're still going to test this chapter, but instead of having one big test over chapter 3, we're going to have two big quiz, small test. I'm going to call them a quest because they're not really a quiz, more valuable than a quiz, not really a test. So instead of having one big 100-point test, we're going to have two 50-point quizzes kind of thing. Okay? So it's important to also note that in chapter 3, the first section should be pretty easy for you guys. It should be mostly review. And then the next couple sections are applications of that. So it's really important that you really understand the first section. So make sure as we go through this today, hopefully it's review for you. But if you do have questions, please make sure you ask because that's going to make the next couple sections even that much harder. Okay? So the first section is it's solving right triangles. Something we should have done in the past, but basically what we're doing is solving any right triangles. Okay, so the first thing I want to be able to do here is we want to name our triangles. So for consistency's sake, we're going to always name our triangles triangle ABC. Notice we're using capital letters for the angle measurements, right, and lowercase letters for the sides. Now, we're always going to name angle A and side A, and we're going to have side A always opposite of angle A. And likewise, angle B, side B is going to be opposite of that. Angle C is our right angle, so that C is going to be our hypotenuse. And we are, for the sake of this chapter, always going to keep C as our right angle. But you could flip-flop the A and the B, right? So if we had a different right triangle over here, and we said my right angle C, which means this is little c, and let's say I put the A up top now. Well, if the angle A is up top, that means side A is going to be opposite of that, okay? And then angle B would be here, which means side B is going to be opposite of that. We're always going to keep our sides and angles opposite of each other just for consistency's sake. Make sure we're all talking about the same thing, okay? Now, we should have all seen SOHCAHTOA in the past, right? And the most important thing to be able to do with SOHCAHTOA is spell it. SOHCAHTOA. And what does it stand for? Well, we've known that means sine of any angle is equal to opposite over hypotenuse, right? So that means, like I can write a proportion, sine of angle A is going to equal the side opposite of A. The opposite is going to vary based on what angle we're talking about. If I'm talking about angle A, well then the side opposite of angle A is going to be side A. The hypotenuse is going to be C. If I say I want to write a proportion with sine of angle B, well, that changes my fraction because now we're talking about angle B. Angle B is up here. So opposite of this angle is going to be side B, but the hypotenuse is C, okay? So either one of these proportions can work, okay? But that's basically what that means. Remember, we call it opposite because it really depends on what angle we're talking about, okay? And adjacent means next to. Now, keep in mind, Something we don't always talk about is this opposite. It's actually called the opposite leg, okay? And this is the adjacent leg. All right triangles have two legs. They're the two sides that meet at the right angle. They're the two small sides, okay? These two sides are legs. That's the hypotenuse. So it's not like the opposite side. It's actually the opposite leg, okay? So we're never going to use the hypotenuse as one of those two, okay? Adjacent just means next to. So I could write a proportion with cosine using this triangle and say cosine of, let's say, angle A. We always have to decide what angle we're talking about. Cosine of A, well, A is here. The adjacent leg to A would be side B, over the hypotenuse would be side C. Or if I wanted to do cosine of angle B, well, from B, the side or the leg adjacent to it would be A, over the hypotenuse is C, okay? So we could write those proportions. It's also important to note we never really use the right angle in using SOHCAHTOA because we already know that's a 90-degree angle. And if I say sine of 90, well, we already know sine of 90. Sine of 90 is 1. So, it kind of messes up this proportion, which actually this one works out really nicely because the side opposite of C would be the hypotenuse. Hypotenuse over hypotenuse, yeah, that would be 1. But it doesn't really get us anywhere, okay? So we never use the right angle with our lead. We only talk about the two acute angles, okay? And then that also means tangent is opposite over adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, and I can write a couple of proportions. Tangent of angle A, well, angle A is here, opposite is A, adjacent is B, so tangent of A would equal A over B. And likewise, tangent of B, well, from B, opposite is B, adjacent is A, so B over A. Okay, so we need to be able to write our proportions. Yes, we do have our other three proportions, and it does hold true that if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Some people do like to use these. I find everybody that tries just makes a lot of silly mistakes. So these do hold true. I don't like to use them very much when we're solving right triangles. They do work, but I find they're more trouble than they're worth. So I don't really like to talk too much about those. Okay, so basically this whole first part is going to be, we have to be able to solve our triangles. Solving triangles means we have to be able to find every single angle measurement and every single side measurement. Okay, it's not just we're trying to find one side or one angle. We have to be able to find everything. I'm going to ask you to write your answers like this, okay? And I do that for a couple reasons. One, all your angle measurements are here, all your side measurements are here because they're uppercase and lowercase. It makes it easier on my part to grade because when you put your answers in here, sometimes they get really hard to read. You guys are a little sloppy sometimes, and you draw your triangles really small. It just gets almost impossible to grade. You're also going to find later on as we go, writing them like this is going to make your life a little bit easier when it comes to checking your answers, okay? So please just make sure you're writing your answers like this, okay? Now, in this case, they gave us angle C is a right angle, okay? They gave us angle A is a 25-degree angle, and they gave us side B. Okay, I know that's side B because it's opposite of angle B. Okay, so the first thing I do is I put the given information in there. Now, we can find this first angle really easily because all your angles have to add up to 180 degrees, right? So we know we can just use basic subtraction. 180 minus 90 is 90. I can just do 90 minus 25 and get my 65 degree angle. So I know this angle here is 65 degrees. Anytime you know two angles of a triangle addition where they all have to add up, 25 plus 65 plus 90, remember all your angles, interior angles of a triangle have to add up to 180. Use that fact, okay? So that's easy. But we still have to find the sides, okay? So what we're going to do is we're going to pick, I always like to use the given information. I try really hard not to use any information that I find, because if I make a silly mistake and I say 90 minus 25 is 75, I make a dumb arithmetic mistake. Well, if I use a wrong answer to then find another answer, well, then that's obviously going to be wrong. So as much as I can, I try really hard to stick with the given information to solve everything else. So from the A, let's say we want to find side A. Okay, so from the A, I'm looking for side A. That's the opposite side, right? Because we've already decided we're going to use the 25, so that's opposite, right? And then we look at what other piece of information is given. Well, we're given the 32. We have to use that, right? So if I'm from the 25, if I'm opposite and I want to use the adjacent, well, that tells me what trig function that I'm going to use, right? If I'm dealing with opposite and adjacent, that tells me I have to use the tangent equation, right? So I haven't decided what trig function I'm going to use until I know what I'm dealing with, right? I'm looking for the opposite side, and I need to use the 32, which is the adjacent. So I'm going to write a tangent equation. So tangent of my angle, 25 degrees, has to equal the opposite side, which we don't know, which is side A, over the adjacent side, which we do know is 32. You have to have two pieces of information to find the third. That's the basic way SOHCAHTOA has to work, okay? If I tried to write a sine equation, right? If I said sine of my angle, 25 degrees, well, sine is equal to opposite, which is side A, over hypotenuse, which we don't know. I can't solve this proportion right now because I have two unknowns. I have to write one that only has one unknown, okay? Now, when you solve this, solving SOHCAHTOA equations, this is nothing more than a basic butterfly problem, right? You're going to do A times 1, which is A. I've got to do 32 times tangent of 25. And that I can just use my basic calculator. Make sure you are in the correct mode. Okay, these are all degree questions, so I have to make sure I'm in degree mode. Okay, so I would just type in 32 times the tangent of 25. Make sure hit enter. Okay, so I know side A is 14.92. Now, it's important to note if you type it in the other way, tangent of 25, you have to make sure you close that parenthesis before you hit times 32. Okay, it doesn't matter which way you times, but if you type the tangent in first, make sure you put that closed parenthesis in there. Otherwise, it won't work. Okay? So we just found this side is 14.92. Okay? Now, 14.9 is fine. Now we got to find the hypotenuse. Well, there's two different ways we could find the hypotenuse. Any right triangle, we can use our Pythagorean theorem, a squared plus b squared equals c squared, okay? We know two sides. I can absolutely type that in. Basically, now I want to make sure you guys also know I'm going to be pretty picky when it comes to grading these. There is a difference between typing in 14.9 squared, like this. I'm using a rounded number, okay? Plus, and I would do 32 squared, get that answer, and then square root it. This answer here is going to be a little bit off. Now, it's not going to make much of a difference, but if I, instead of typing in 14.9 like I did there, if I just grab the whole thing and say, that's my 14.92 squared plus 32 squared, and then square root that, oops, hit the wrong button, square root that, I'm going to get a slightly different answer, right? This one's 35.29. Yes, this is, but basically this isn't much of a difference, but I point this out because while in this problem it wouldn't have made much of a difference, later on, if the numbers are bigger, it absolutely will. And you mathematically may not do anything wrong, but if you use a rounded number in a calculation to find another answer, know that your answer is going to be close. There's sometimes you'll be off by 20 or 30, especially if those numbers are big. Okay, think about if these numbers are basically just times them all by 1,000, instead of being off by, basically 1/100th. Well, now you're going to be off by, 1 or 2, or 10. Okay, so I will be taking points off for that. So please, please, please try not to ever use a rounded number to calculate another number. You can round your final answers, but just don't use it to find another answer. Now, that's one way I could have finished this problem. Another way I could have finished this problem is just to write another SOHCAHTOA proportion, right? If I want to use this 25 again, and I'm looking for, in this case, the hypotenuse, I can use the 32 to find the C, because this is from the angle adjacent hypotenuse. That's cosine. I could say cosine of my 25-degree angle is equal to adjacent 32 over the hypotenuse. And I could just write another proportion like this, instead of using a squared plus b squared equals c squared. Now in this proportion, I would have to do 32 times 1, and then I would divide by the cosine of 25. So I would type in 32 divided by the cosine of 25, and I should get the same answer as I got right here of that 35.3. So it doesn't really matter which way you decide to solve this. I personally like the second way, where we're just writing this. I think it's easier to type these into your calculator than it is to, finish your or your Pythagorean theorem. But to each his own. But basically, you have to be able to find all of those. I actually like to use the Pythagorean theorem as my last step to kind of check my answer, because I know this squared plus this squared has to equal this squared. All right, so I can kind of double check that. That's a good way to double check your answers. Okay, so let's try another one. Let's say this is some given information right here. Okay, and this is how your tests and quizzes are going to be kind of laid out, right? Basically, they don't draw it for us. So your drawings can kind of, I would put my C in right here. C is 90 degrees. Label that as little c. And then where you put the A and the B is kind of your choice. 32 degrees, I personally would put it over here. So I'd put my B here just because I know that's kind of smaller, right? I know this is going to be bigger than 32, so I try to put the smaller one where it goes. So I know this is 32 degrees, 12 minutes. And I know side A, if that's my B, my A is up there. That means my 22.14 goes down here, okay? So again, now it just becomes, what do you want to solve for first? If I want to solve for side C first, well, from my given angle, adjacent hypotenuse, that would be cosine. So I'd say cosine of 32 degrees for 12 minutes is equal to adjacent over hypotenuse. Oh, by the way, to find that missing angle, again, it's just subtraction. Remember, there's 60 minutes in a degree, so it's kind of like a times subtraction. By the way, if you want to use your calculator can handle this. You don't even have to put the degree symbol on the 90. You could just do 90 minus, and then you would type in 32, go to your angle measurement, get your degree, 12 minutes. Make sure you put your minutes symbol in there. It can handle this subtraction, but it puts it as a decimal. So then you have to go back, go back to your angle menu and do that as degree, minute, seconds. And then there's your other answer. So Again, by the way, your angle ABC. This is how I want your answers, ABC. Put in your given information here. They gave us a 90. They gave us the 32 12 minutes. And they gave us side A, which is 22.14. Okay, we just calculated that the missing angle was 57 degrees, 48 minutes. Okay, and again, my rule is if it starts in degree minute seconds, I want it ending in degree minute second. Please don't put it in, mix it up with some degree minutes and some degree decimals. Okay. All right, so we got this proportion. We said our cosine is adjacent over hypotenuse, so we have this proportion. Again, this is just a butterfly. I would do 22 times 1 divided by that. So in this case, I'm going to do 22.14, in this case, divided by cosine of, and then I would need 32, go to that angle menu, degrees, 12 minutes. So go back to that angle menu, get that minute one, that's the second one. I like to close parentheses just to make sure I know what I'm doing, and then I can press enter. And I know C has to be that 26.2. Okay, so I'd come over here and say side C is 26.2. Now again, I have a leg and hypotenuse. I could use a squared plus b squared equals c squared to solve that. I personally don't like to. I would go from here opposite adjacent. So I would just do tangent, and I would say tangent of my 32 degrees 12 minutes is equal to opposite over adjacent. So in this case, I want to multiply. And by the way, you can do a little cheater thing with this. If you go up and grab where you typed it in, grab it. Now I can just go back and change it. I want this to now be multiplication, because the way I would butterfly this is I would just times, right? But I don't want that to be cosine. I want that to be tangent. I don't have to type it all back in, and I can just press enter. Bam. So I know that answer is 13.94. And by the way, another good check is, remember the rule in geometry, the biggest angle has to be opposite the biggest side. Smallest angle, smallest side, okay? That's a quick check just to make sure that things look right. Doesn't necessarily mean it is right, but it's a good double check, okay? All right, what about one like this? And this one's a little bit different, because if you draw it out, okay, we have, here's our angle C. They're given that's a right angle. And then they say that we know this is, side C is 7.25. And let's put our A up here and our B here. B is 4.37. Notice, in this case, they didn't give us either one of our acute angles. They gave us two sides instead, right? Now, obviously, I can find that third side really easily just using Pythagorean theorem. I can just say 4.37 squared plus A squared equals that 7.25 squared. And I can just type that in as, I personally would do the square root of, I would do 7.25 squared. In this case, I would have to subtract, right, the 4.37 squared. Okay, and bam, I know that answer. Okay, so I know right away A, B, C. I know that's 90. That's the only angle I know. Now I know all three sides. So I was given the B was 4.3, that's a 3.7. I was given the C is 7.28. And using Pythagorean theorem, I just found that that was 5.78, 5.8. Okay? Easy enough. But now we have to find an angle, okay? We don't know either one of those two angles. So step one, pick one, whichever one you want. Let's say we want to do B. So from the B, what two sides do we know? Well, technically we know all three, but I'm not going to use the one I calculated. I'm only going to use the one given ones. So from the B, opposite and adjacent, right? So that's a sine equation. So if you write a sine equation for that, sine of angle B is equal to opposite 4.37 over 7.25. Well, we know how to solve these, right? We know how to get rid of that sine. All we're going to do is use that inverse sine button, okay, and type that right in. So we have to do the inverse sine. Anytime you're looking for an angle, it's going to be inverse. Inverse sine of that fraction, 4.37 divided by 7.25. And that should give us our angle measurement. So we know angle B comes out to that 37.1. So we know this is 37.1. And now, anytime you know two angles, the easiest way is subtraction. Now, you could do another proportion, but I wouldn't do that. I would just do 90 minus that, 37, and bam, there's your other angle right there. It's 52. Okay? So if they give you two sides like that, instead of one of the angle measurements, you are going to have to use an inverse to find that. Okay? It doesn't matter if you set that up. If we would have said, let's do A first. Well, from the A, that's adjacent in hypotenuse now. So I would have said cosine of A equals the 4.3 over the 7.2. So 4.37, 7.25. Notice it looks very similar to that, but now we're doing cosine. And if I did the same thing and typed that in and said, instead of inverse sine, if I said inverse cosine of that, I should get this other 52.9. Okay? And then that would have went there. If I would have subtracted, I would have got that angle there. So it really doesn't matter the order in which you do things. Okay? So try a few of those problems. Let me know how it goes for you. Again, hopefully most of this stuff is all review for you. You've used SOHCAHTOA in the past. Just know that the book, is for the most part not going to draw things for you on your test and quiz that I give you on this one. I'm not going to draw them for you either. I'm just going to give you some basic information. You can go ahead and draw it if you want to. Okay? I highly recommend you drawing them to start. Okay? I will talk to you guys later. See ya.